Okay. 2 weeks ago, the new year of the new Iranian year, Hijri Shamsi, is started. And we had 2 weeks of holiday because of this. Congratulations for the new year. And from this week, we will back to our course. Okay. First of all, I should say that today I will upload the first assignment for you. This assignment is about reviewing and finding some information about data sets. I will introduce a data set to you. You should download it and review it and give me a report about the number of attributes and type of attributes, statistical data of attributes, and something like that. I will ask you to do everything that we learned in chapter 2. About on the data of these data sets. I will upload the assignment in the LMS, the home page of the course in the LMS. So please be care about that. After chapter 3, I will use Veka. I will show you how we can use Veka in our course to pre-processing and then applying data mining methods. Veka is a very simple software in data mining applications, and you can do it simply. But I will prepare some links to for video of how to use Veka. Okay. Is there any question about the past teach contents, about the contents in chapter 1 and 2, chapters 1 and 2? Is there any question about them? Yes or no? If you have any question, please ask me before starting content of the uh, content of the new lecture. Okay. In the second chapter, we learn about data types and attributes in the data sets. We learn the difference between different data types and prepare some statistical information about those attributes, those numerical attributes or something like that. Today, we are going to talk about one of the most important steps before starting data minings. In the past, we say to it in chapter 1, we say to we say that before starting data mining, we have to apply some pre-processing tasks on data. But why? Let's suppose that I receive a dataset. This datasets can have different size. Has different size. It can be small datasets or very large datasets. This dataset is gathered, I don't know, by automatic tools or by hand, or I don't know, by everything that you can think. It consists of some data, and maybe during the data gathering process and during the recording of this data into the data sets, maybe some data affected by environmental faults. For example, the data is changed um, because of noise, or because of some failures in hardware, because of some faults, some human operators faults. I don't know. What does it mean? It means that my data maybe is not correct. The quality of my data, maybe, I will repeat the phrase maybe my data is poor. If I use poor data for data mining, this poor data will affect my results too. This poor data can deviate the results, the final results of data mining process. So I need to do something to improve the quality of data in a dataset. Maybe my data is gathered from different datasets. I have some different datasets, some heterogeneous datasets, and firstly, I should uh, create a new dataset from those primary datasets. Maybe, I don't know. But how can I improve quality of those data? It's a very important question. How can I improve the quality of data? Why? Because consequently, this improvement will affect the results of my data mining process. So, in this chapter, we will learn how we can improve the quality of data. But first of all, I should answer a main question. What is quality of data? When I'm saying the quality of data is poor, what does it mean? What is quality of data? I'm an engineer. When I'm talking about something, because of my engineering field, I have prepared some quantitative measures, not qualitative measures. When I'm saying that A is bigger than B, it's a qualitative measure. What does bigger than means? I don't know. But when when I'm saying that A is 2 times bigger than B, 2 times bigger than B, this is a quantitative measure, a measure with a number. I'm an engineer. I need something like this. I need some quantitative measures. So when I'm talking about data quality, I should prepare some measures to say that, okay, this data is poor. Why? Because of this measure. This measure from from viewpoint of this measure, this data is poor. This data is rich. So what are measures for data quality? It depends. It's a multidimensional view. Most of the time people talk about accuracy. Accuracy is the main measure for data quality. Accuracy means that something is correct or wrong. Something is true or false. Something is accurate or no. So accuracy is one of the most important measures for data quality. Sometimes we are talking about completeness. Completeness means that all features, all attributes in, in the data set have enough information, have recorded data. They have not missing values. When some data are unavailable, it means that we say that they are missed. Missed value means that there is no information, recorded information in that feature. So completeness means that not recorded, means that all record uh, must have proper values. The second measure is consistency. Consistency means that I make some changes in a record. What about the related records to the changed, to the edited record? I edit a record. So what about the related record to this record? For example, I'm changing my student number. What about the other tables? related to my student number. For example, if I change my student number to something else, I have to change it in the rest of tables in the university. I have to change them. For example, if I change it in education section, I have to change it in dormitory, for example, section. In all of sections, all of offices in the university, I have to change my uh, student number. Otherwise, they cannot recognize me. Why? Because my student number is changed. There are some relations between different tables using foreign keys. The primary key in the first table can be a foreign key in other tables. So if the primary key is changed, this change must be applied in other tables too, because of consistency, keeping consistency between different tables. Otherwise, we will lose some information because we break the relations. So consistency is another measure. Timeliness. Timeliness means that some information needs to update it frequently. During the time should be updated. Yes or no? Some features needs something like this, needs to be updated frequently. Some of data no, does not. Believability means that can I trust the data? Are data correct? Maybe I receive some data and there are some fake data in the days inside of them. The fake data can affect my results. Maybe simple statistical results. The fake data can affect them. Can affect them. Can I the believe data? For example, I'm working on temperature. Okay. During the time, I see that the temperature of Iraq in the spring is about, for example, is something between 20 to 27, 28. If I receive some new information that the temperature in Iraq is 13, can I believe on this data? I know that during the history, the temperature is a number between 20 to 27. Can I believe to 13? Or can I believe to 41? 41 degree of Celsius? Can I believe on this data? Yes or no? Are these data correct? Yes or no? It's another measure. And interpretability is another measure. It means that my data can be understood easily, yes or no. Sometimes we need to understand some data. Most of the time we need to understand data, but sometimes we have to uh, talk about this interpretation. Why? Because, for example, someone asked me to do something. For example, last year, uh, I had some data mining process for electrical distribution company of Iraq. They asked me to do something. I spent some months to understand what the data are. Why? Because I had to interpret the relation between those data. Those data was about uh, their billing systems. So there were some uh, information to calculate the billing and some information about final payment and something like that. And when I'm working on those data, I had to uh, understand the relation between those data. Interpretability means that how easily the data can be understood. If it's easy, I can work with those data correctly. But if it's not, if it's hard to understand the data, so it's possible for me to make some uh, incorrect to apply some incorrect methods on my data. It's not a good question. It's not a good situation for me. Finding, receiving a bad understand about data and then applying wrong methods on data. So my final results uh, will affect too. Okay, so I'm trying to I'm trying to improve the quality of data before starting data mining process. How we can do that? As we talked, we have different types of data. We have different features with different values and very wide elements affecting on data in my data. But in summary, I can mention four different major tasks as the pre-processing steps before working with data in data mining process for different tasks as my data pre-processing. Because in chapter 1 we talk about this, that we need to apply pre-processing steps, tasks to improve the quality of data before applying main algorithms of data mining in our data. Four major tasks in data processing are these cases. First, data cleaning. I have some data. These data may have some missing values. These data can be affected by noise during the transferring from point A to point B. Noises can affect my data. They can change value of my data. Maybe there are some outliers in my data. As we show in chapter 2, outliers can affect the results. So I should identify them. Maybe I should remove them. Maybe some inconsistencies are between different datasets. Data cleaning is an answer to all of these problems. To filling the missing values, to smoothing noisy data, to removing outliers, detecting or removing outliers, to resolving inconsistency. I don't know. To recover such problems. The second task is data integration. Data integration means that uh, gathering information from different datasets into a single dataset or into a data cube. In chapter 5, chapters 4 and 5 of our textbook, uh, the others talk about data cube creation. Here in this course, we don't talk about them because we have not enough time. And creating a data cube is not a major part in data mining. It's a pre-processing step. But if someone likes to read about data cube creation, he or she can uh, read chapters 4 and chapter 5 of the textbook. Data cube uh, is similar to a multidimensional array. For example, a 3D array. In 3D array, in each cell consists of some information related to all of those 3 dimensions. Each cell, value inside of each cell is related to them. Okay. Uh, the third task is data reduction. Data reduction is one of the most important pre-processing steps in data mining. They are divided into three subtasks: dimension reduction, numericity reduction, and data compression. We will touch them deeply, but dimensional reduction means that removing some features on some records to decreasing the volume of our data, because some information in dataset are not necessary or are not related with our tasks. When I'm starting to do data mining, to applying some data mining techniques, before of this, someone asked me to do a task. Okay, I should select just related information to that task. If you remember, in chapter 1, we say that data mining is a task related application. If you change the tasks, if you change your position, if you change the data, maybe the past method, uh, fails in the new condition, under the new conditions. Maybe it's a task related application. So data dimensionality reduction means that we need to reduce the volume of data, features or records, into some data that are related to our tasks that we decided to do. Numericity reduction means that uh, we can reduce total number of data in for different uh, features, and data compression means that how we can uh, compress and reduce volume of data using some techniques. It differ. It's not. Uh, it differ from dimensionality reduction. Comparison uh, happens on all data. We have to compress all data, but dimensionality reduction means that we should remove some data. In data compression, we never remove data. Okay, and the fourth task is data transformation and data discretization. What does it mean? Uh, when we work with data, for example, someone asked me to do something on a data set, and the data set has two features: age in the range between 1 to 100, and salary in the range between, for example, 10,000 to 200,000. Okay, as I see here in this case, I see that the range of age feature values in the age feature is much smaller the range of features, the range of values inside the feature salary. In the feature salary, the range is about 2,000, 200,000, but for the age, the range is 100, 100. So we can see these ranges are far from each other. If we decided to, for example, make a decision according to the age and salary, the bigger values in for salary can affect the results because they are bigger than values in age. In this case, we have to use normalization. We normalize age and also salary. Then both of them, the range of both of them will be something between 0 to 1. Then their value cannot affect widely on my results. And sometimes we need to use hierarchy. For example, address. Iran, Markazi provenance, Iraq city, and in Iraq city, for example, Sardash and Iraq University. It's a hierarchy. When you are using this hierarchy, you can receive lots of information. But if you need more information, you can go more deep in this tree, in this hierarchy, to receive more information. So in the fourth task, I have to change type of data and features of each feature, the nature of each feature, to overcome some problems. To create a better situation for thinking and making decision. So sometimes I need to do data transformation or maybe data discretization. We will talk about them in this chapter. Um, and right now, we will start with data cleaning. When we are talking about cleaning, cleaning is against dirty. They are counterpoints, cleaning and dirty. In real world, my data always my data is dirty. It means that my data can be incorrect, can be, maybe, or it may potentially incorrect. Why? Because of instrument faulty, because of fault of human, because of fault in computers, because of faults or errors during transmission, or because of everything. Because of everything, my data can be affected, and my received data and my stored data can be incorrect or can be dirty. So we have to talk about dirty. What does it mean? We have four different types of dirty data. The first one is incomplete. Incomplete means that in a data set, I have some cells or some features in different records or in different tuples. I have some features that they are not containing information. They are empty. They lack they lack values, attribute values. For example, here, occupation is equal to empty. We call this as a missing value or missed data. The value is not here, is not presented in the data set. Why? Because of different problems. For example, most of the time in database applications, some features are optional. What does it mean? It means that I can put information in optional features, or I can pass them easily without filling data in them. When I pass them with no data, their value are missing. I cannot talk about these missing values because I don't know what is inside those. What are the reality of data in those features? Occupation is empty. The operator doesn't enter information about the occupation of someone. Sometimes the data is entered, but because of noise, because of noise, environmental noise, the data is changed. So the value inside the feature is not correct. It has some errors. For example, salary is equal to minus 10. It means that someone worked for me and at the end of work, he gives me some money too. All the day he worked for me, and at the end of the day, he gives me some money too. It's not correct at all. It's not correct. If someone works, I have to pay to them. So salary is always a positive value. Salary is equal to minus 10 is not true. It has some errors. It's incorrect because of some noise, some errors, some outliers. We should care about them. This data is not clean. It's dirty. Why salary is minus 10? Why? It happens because of some faults, some errors, some noise, or because of something else. We should be care about this. This is a noisy data. The third group is inconsistency. Let's suppose that in a web page, in an application, I ask someone about their age. Someone say that my age is 42. Okay. And also I ask from them about their birthday. They said that my birthday is March of 2010. Is it true? Of course, no. We are in 2021st, year 2021st. So if the birthday is 2010, so that people must have only 11 years old, not 42. They are not consistent to each other. They are opposite to them. Or for example, I have two systems. In the old system, I have a ranking system. In the old system, my ranking was 1, 2, 3, and in the new system, my rank is A, B, and C. The last one, the ranking is in the last one was numerical, and now I'm using characters to present the rating system. Which one is correct? Both of them. But how can I make a relation between them? In the past system, I'm using the rate 1, 2, 3, and now I'm using the rating system A, B, C. I'm changing the rating system. If I'm trying to work with both of these tables, I have to put, I have to use a software or a system, some codes, to change these rating systems to each other. Changing 1 to A, for example, B to 2, and C to 3. I have to use this changing system. Otherwise, I couldn't make a relation between these two rating system. One more example is discrepancy between duplicator records. What will have if my records are duplicated? When we are duplicating some records in our datasets, it can affect the rest of data and my results, my final results. For example, I have 3 marks. Okay, 3 marks, 15, 17, and 19. Their average is 17. Oh, excuse me. Their average is 17. Okay, but because of some problems, the value of 19 is repeated or duplicated. So my data is 15, 17, 19, and 19, on also 19, for example. The 19 is repeated 3 times. If I'm trying to calculate the average again with 15, 17, 19, 19, 19, in this case, the average is about 15.8. Just I repeat the value 19 3 times. I had 3 marks, 15, 17, and 19, but I'm repeating the value 19. I can see that the average is changed. This is very important. Duplicated records or repeated record can affect the result, the final result. In this simple case, I show you that how just a simple repetition, how affect the result. The average is changed. So we should be care about something like this. This is an inconsistency in data. I have 3 marks, but here in the second case, I can see that 5 marks are presented and entered into the average process, calculating average process. Okay. One more group for dirty data is data with initial values. It's a simple case. For example, in most of forms, web forms or application forms, the default is when I'm trying to input data, the default for sex or gender is male. The default is male. For birthday, the first day of the year, January 1st. This is the default value of the birthday. When we are putting some default values, maybe the operator, the man or woman who is enter data, maybe he or she can change the default value or may not change the value. Then what will record in the data set? If the default value doesn't change, the birthday January 1st, the January 1st will record for all of the cases, for all recorded records, for everyone. January 1st will be recorded as their birthday, January 1st. Is it true? All people are born in January 1st? Of course, no. This is a dirty data. The data has an initial value, and the operator, the people who enters data, doesn't change the initial value. Again, in this case, we miss data, we miss real data. And the data is filled by a default value, by an initial value. Again, we miss the data. Okay. So sometimes we have not all data. Because of some problems, some technical problems. But also sometimes we miss some values, some data because at the time that we are recording data, those values were not available. For example, I'm in a supermarket and I'm a seller in the supermarket and someone comes and buy something, okay? And I'm asking them, okay, please give me your name and your cell phone number. He or she gives them to me. Okay. Can I ask him or her that please give me, mm, please say your uh, amount of salary or how old are you? Maybe someone try to answer me, give me an answer. Someone, but not all of people. Most of people does not like to say their real age, or most of people does not like to say about their real income value. So in this case, I see that some value are not available. I'm trying to enter data, but some data like as same as income, age, or something like that, maybe address. Some data are not available at that time. So when we are talking about missing data, we should be clear that missing data can be present in all data set because of different situations. For example, an equipment in the process when from the starting point when I'm trying to gather information until the storage and reading data from dataset into data mining process. An equipment in this line pass, a dataset, an equipment has some errors and has some malfunctions. So it can affect my data. It can change my data. Maybe some inconsistency are inside my datasets. Fun data is removed and its related data are still present in the datasets. The related data are not removed. Maybe the data is presented, but no one can understand what is the data. For example, someone has a bad writing. I cannot read his or her handwriting. I cannot read, and so I cannot understand what he says. When I cannot understand, I cannot enter data in the datasets. Maybe some data are not important at the time of recording. And this time, I had some information that are not important. So they are optional. So simply I remove them. But in the future, I see that okay, this attribute is important for me. We say that the data mining process is an application oriented or task related process. The data were not important, but now it's important. So say that those information are missed because they were not important and no one tried to fill them. Someone we made some changes in data and datasets. For example, in datasets, I'm adding a new feature to datasets. So when I'm adding a new feature to present datasets, the value for that feature, for the new inserted feature, is missed for the current feature, for the current records. Maybe for the new records, I can add them, but for the past records, the value of the newly added feature is missed. Maybe I have a table and I'm changing data type of a feature. For example, in the past, the type of feature was character, and now I'm changing it to number. So all characters under the uh, changed feature, all characters should be removed. They are incorrect. They are missed because right now the type of that feature is numeric, nothing else. Characters are not acceptable. So when we are changing data or we are changing the tables, some data can be missed during the changes. And now, what should we do with missing data? The simplest, the simplest method for handling missing data is to ignore the tuples with missing values. It's a good option when number of tuples that have missing values are rare in a big data set. I have a large or big data set, and only some of the records or tuples in that data set is has um, excuse me have missing values, only some of them. So I can simply remove those tuples. Nothing else. It's very simple. But again I repeat, when number of missed values and tuples with missing values are rare or very small, removing or ignoring the tuples with missing value can affect datasets. But when now total number of those tuples is very low, it's not important. We can simply miss or ignore those tuples. The other way is that filling some values instead of those missing values. I have some missing values. I can put some predefined values in those missed values. I can do it manually or I can do it automatically. It doesn't important. I can do it if the data set is small, I can do it manually. But if the data set is large, I should do it by tools or by software. I don't know. I should do it automatically. For example, for a specific features, for each attribute that has a missing value, I can use a global constant. For example, the phrase unknown. Instead of using empty or missed value, I can put the phrase unknown or something like that. Instead of putting missing values, I can use this. I can use this. Most of the time, if the attribute is a numeric attribute, this type of attribute is number, is numeric. Most of the time, we are using mean value to solve the problem of missing data. It means that I am calculating the mean value for all known data in a column or for an attribute. I'm calculating the mean value for all known values, and then I'm putting this mean value into all missed values. So each missed value will receive a new value, mean of attribute or mean of other attribute, mean of values of that attribute. If I have a data set with some classes, for example, 2, 3, or 4 classes, something like that. A smarter method is that for each class, for each attribute, we calculate the mean value of that attribute for that class. For each specific class, we are calculating the mean value of each attribute. And then we can use this mean value, we can apply this mean value to the samples belongs to that class. It's a smarter option to handle missing data. But if we are if we are trying to find an intelligent way or a more clever method, we can use Bayesian formula or decision tree. Decision tree is a tree in data mining that can give us some decision points. It can be used simply for all decision making systems. We will talk about decision tree in the future in this course, but using decision tree or using Bayesian formula, we can create a model and then according to that model, we can predict the missing values of that attribute. It has some preliminaries and mostly decision tree can be used. Decision tree is used to predict class labels. What does class labels means? For example, about let's suppose that we are talking about cancer. Okay, someone comes and come and give test for cancer. Okay, the result maybe is yes, true, or false, yes or no. So I have two classes: class true or yes, and class no or false. This is a two class example. Decision tree and some other methods can be used to make a decision and finding the label of this class. The patient comes and I will get his or her information, and decision tree can make a decision that this patient has cancer, yes or no. So part of missing value, part of handling missing values can be applied using classifiers in data mining. Decision tree is a classifier, but simpler ways such as removing some tuples or using constant value or mean value can be applied too. It depends. It depends to our job, to our tasks. What should we do? And also depends to our data sets. What should we do? It depends on the cases. But we can apply something like these methods to handle the missing values. Okay, our time is finished. Next Tuesday, I will see you and we'll continue our lectures. And this is enough for today. Is there any question? Is there any question? Okay. I wish the best for you, and thank you for joining and listening to the lecture.